Hello again and welcome to the Algorithmic Trading School for Beginners using cTrader. This is video 4, and in this video we're going to explain in more detail the risk management robot, how to write it in Visual Studio. We're going to go line by line explaining the cTrader or cAlgo API and how that integrates with your code. This is assuming you've looked at the videos previously, which was an overview of the cAlgo platform. An overview of the Visual Studio 2015 and how that integrates with the cAlgo platform, and a video we did on coding standards and design and why it is important to start from the very beginning writing quality code, especially if you're dealing with money and it's in a financial area. So the next video we're doing now is this one, how to write a risk management robot with Visual Studio. This robot is a simple robot, but we've tried to cover areas including date and time, and how the different events of cTrader work. We'll show you that later. So the first thing we did was just create a very basic requirements document, and you can access it here. And the document, you can create your own document how you want to do it, but writing a document will help you think about how you want the system to work. It will save you so much time in the long run. It will reduce bugs. It will make it work how you want it to work, and it will also make you think about things you've not thought about. So it actually covers areas you didn't think about. So if you're looking at managing your risk on your trading robots and you do your design up front for this risk management robot, it will save time, save you money, and you really want to be looking at doing it this way, and I'll show you why in a minute. First thing you want to do before you start writing your user-defined parameters, which is the parameters that are going to be used in the bot, is actually write a description of how you want the bot to work, how what you want it to do. And in this case, it's very basic. It's a single robot is required that will stop all trading robots at a set time during the week. It will mostly be used on a Friday afternoon, as all trading must stop 2 hours before the markets close. An option is also required to close any open positions. So what they're saying is, this trader, say in this scenario, doesn't want positions open over the weekend because they're a day trader. They don't have long-term positions. They're on short-term trades, maybe a few hours, and they don't want anything running over the weekend because of the chance that some kind of news release might occur, or the price might move a very large amount over the weekend. You can't close your positions over the weekend. You've got no control over it. And on a Monday when the markets reopen, there's a gap of say 100 pips and you've lost a lot of money. You have no control over that when it's occurring. So to play safe, some traders actually close their positions on a Friday afternoon and they just don't trade on a weekend. They just leave there because you don't know what's going to happen. Again, this is just a scenario. So once you write your description, from your description you should pick out your parameters. You'll pick out your key values that are going to be used in your design. So in this case, you're picking out your trading hours, your start and stop time. I'll go back up here. And whether you want to close all positions or not. So your design will actually be driven from your description and show your design of your code, especially if you were doing object-oriented programming. I don't want to confuse you too much, but this would be a unique way of doing it. Sorry, the right way of doing it. So example of operation. So if you put a few examples how you want your robot to work, and in this case, on a Friday afternoon at 1500 hours, you want all automated trading robots must stop trading, and all open positions must close. There must be no trades open over the weekend. That's an example operation. You can do various different ones because there'll be different scenarios depending on what type of robot you're doing. Any special rules? So it's things that you didn't really think about, and this helps you think. And it's things like, what if the robot fails to stop the trading? So what if the risk management robot fails for any reason to stop a particular robot from trading, from stopping trading to stop? You want to be sent an email alert to say that's occurred. If for any reason that you send, say you've got 20 positions open, you send 20 requests to the broker to say close all my positions, but 3 of those positions didn't close. You want to know that those 3 positions didn't close. Why? You want to be sent an email to say that 3 positions haven't closed. At least you can then try and do something about it. If it's something that you know that weekend, I mean, manually you'd probably close these. So manually you'd probably close your trades and close your positions if you're in front of your charts on a Friday afternoon. But this robot is probably for people that have got a full-time job and they're driving home on a Friday afternoon, in traffic, and there's no way they can stop and close their trades. Or they're at work all day and they can't log on or access their account to close positions, but they want to trade during the day on a Friday. This is for people like that, and this allows an automated system to manage this for you when you're not at your computer. And these are all scenarios, and many different scenarios, so this is just an example again of what could be done. Again, if a position didn't close, you want to be sent an email alert. So by doing this design, no matter how basic, it helps you think about, before you write any code, about how you want the whole system to operate. This is true with trading robots as well. Again, this is also useful, this document, to keep as the document with the source code and keep it all together as a package for future development. So that when you go back to your future development, you can just review the document, review the code, look at the comments in the code, and understand straight away what's going on. And so you can support and maintenance. It's all about support and maintenance, and it's all about enhancing the code later on down the road. And especially if you add extra features to your robot, if you just go in and start writing code without looking at the design, you'll introduce bugs. Side effects. It could affect other parts of your system. It also helps you write more structured code by, I want to add more features to this risk management robot, so I'm just going to go into the design and I'm going to actually add my extra features that I want to add. And then by looking at the whole picture in a document, you can see that how that affects other areas and how you can implement that logic much easier. Okay, so that's just that. So again, we'll first of all go to the cAlgo system. What we're going to do is go through the code line by line. This video is going to go on for a bit longer than the others. There's only 4 parameters that are going to be used, because at the moment we're not going to use the current the symbol or the time frame. So the parameters are going to be the stop trading hour, the stop trading minute, close all positions, and the time interval. And I'll explain the time interval to you later on. So again, if we go to the code, I'm just going to grab a drink of water. So if we go to the code at the top, the first thing you'll see, as I mentioned in the last video, is referenced assemblies. Now what referenced assemblies are, these are building blocks of code logic that's been pre-built that you want to use in your code. So that is this. What the .NET framework is, it's very powerful. It allows you to add, if you go to references, add reference, it allows you to add a whole library of pre-built logic for doing various different things. Okay, so you've got all of these here for identity, for directory services, for printing, numerics, remoting. There's other things for programming that you can go in here for web development, for speech. So this logic has already been built. So whatever you're thinking of doing, don't reinvent the wheel. Somebody's written that code and they've written it very well, and they've encapsulated, they've put that code into a library. You can just access that code, and you don't need to know it's abstract. You don't need to know how it works. You just use it. And this is the beauty of the .NET framework, and you can add your own library as well, especially with trading. You can add your own library of trading components, so that when you write your robots, you just take it off the shelf and use it. There's no redeveloping code that you've already used. There's not duplication of code that you've already used. The same should be true in your coding as well. You want to reuse the same code as much as possible in your design. So all of these are kind of reusable components. Again, you've got the cAlgo API. That's the programmer's interface for cTrader, and that gets referenced as well. Now to use these, once you've referenced them here, you also have to put using to use the namespace or the library that you want to use out of all of these assemblies. So each of these got different libraries. So each one of these have different libraries, and it depends which library you want to use. I'm going to take out system.timers for the moment. I'll show you why in a minute. I'll go through it later. So these are your referenced assemblies. I put them in regions. We explained that before, and I explained comments as well. The first thing you'll see on your cAlgo robot, because the template that gets created is from cAlgo, they do it as a template framework, is the time zone. The time zone that you specify here, just by going dot and selecting the time zone you want, it says here all dates and times within robot or indicator will be converted to this time zone. There you go. So, but we're using a local time zone, and I'll show you that in later on. So access rights, again, the robot access rights. So cTrader and this API have given this feature and this attribute on each class to allow you to decide how much interaction you want to do with the operating system. Do you want the robot to write to the file system to create text files? Do you want the robot to connect to the internet to get data or show web pages? Do you want the robot to write to the Windows registry? Or do you want the robot to do nothing? There's no access rights. Or you can have full access rights, which means the robot has access to the operating system to do anything it wants. So if you were going to get a robot from somebody else, then that you know what that's doing. But full access is not a problem, because it just means sometimes it's the only way to get access to all the services and kind of logic that you want to use the operating system. Okay, that's just briefly there. Robot, that is just a allows you this value here just allows you to access all the interfaces that come through cAlgo's robot. Oh, I'll just put that back to none because we're not using none at the moment. Okay, first thing you'll notice is the trading time. Yeah, so trading time is actually what we're going to use. It's a private variable. It's a date time data type, and it allows you to store in this value the current time and the date. It stores a lot of other information as well. So this is what we're going to use for deciding on a Friday afternoon to close at a certain time or day. Then we've got our parameters down here, our user-defined parameters. Now these you can change to anything you want. Stop trading hour, stop trading minute. If I go to the robot, you can see it says there, stop trading hour, stop trading minute, and the default values. Okay, so if I go back here, this is where you declare your parameters that are going to be shown in your robot, the values that you want to change. And down here we've got the cTrader event. So what I'll do, I'll just minimize, as I go through, I'll minimize the things we're not using. Make it easier for you to see what's going on. So cTrader events. Now this is methods. Each one of these, each piece of logic in here will get called every time a certain event occurs with the platform. So in this case, again, yeah, in this case on cAlgo or cTrader, when you start a robot, this method gets called, but only gets called once. And this allows you to initialize your variables. And what we're using it for is to configure the timer, getting the current date and time, and displaying into the log file the current date and time. Okay, I'll just show you here. If I go to the robot, and if I clear that, if I start the robot, in the log there, where it says log, it says the robot was started using PC time for trading 9:11. My time is 9:11. Because my time is UTC 0, but I'm showing you a demonstration that the server time is different. It's 11:14. So I'm using the PC time, which is different from the server time. And this is required for backtesting. I'll show you later on why we use that. Okay, and that's all this does. On start, it configures the timer and does the trading time. I'll show you these methods in a minute. I'll just go through the cTrader events. The onTick method is called every time there's a price change on a symbol. So if a news release occurs and the price is moving super fast, there could be many this method, any logic in here will be called many times per second. If there's not a lot of trading going on or it's flat, it might not get called at all, or not very often. So it's not a reliable way to do something like closing on a Friday afternoon. This is why we're using a timer, and a timer will just work every so many seconds. It will check the time. So we're not going to use the onTick. The onTick is very useful. We'll show you later on if you're doing a trading robot, where it uses the price to check if a price is increased to a certain value. Then you use the onTick because you know that when the price changes, this method gets called. The onBar method will get called every time a close of each bar. So a bar is a candle. So each one of these, in this one, it's a 1 hour time frame. So each one of these bars equates to 1 hour. So every time one of these candles or bars closes, that method will get called. Okay, and then you've got onStop. onStop is called when the robot stops, and you might want to use this for cleaning up resources or anything else you might need to use it for. Okay, that's very small events in cTrader. It's not a lot to learn. That's why the cTrader platform or the API is perfect for beginners of algorithmic trading, because it's very basic. You're not going to get lost in it, especially if you're new to programming. It makes it probably a good platform to start off on. They have got some other events, like when a position closes and when a position opens, and some others. And I'll show you those later on when we do the trading robot. Okay, what I wanted to show you was the configure timer and to get the current date and time. I'll go to this one first. What this is doing here, this variable, it gets populated on the start. It calls this method. If I right click this is a method. If I right click and I go to definition, it goes to definition. Or if I go back, I'm going to do Control minus and just show you something. If I hover the mouse over it, what I was mentioning before in the last video, that each of these comments are self-documenting code. The text that you put in these comments are shown when you put the mouse cursor over the method. So here it says return server time if backtesting and local time if forward testing, and local time if forward testing. If I right click and go to definition to bounce to that method, there's the description there. So each description you add to your methods gets shown up in the code when you hover your mouse. So it is good to write these comments, because when your code gets complex, you've only got to, if I do Control minus to go back, you've only got to hover your mouse over there and it tells you exactly what that method's doing. It tells you the return type, which is a date time. It tells you the class name, and it tells you the method name. So all this is doing is saying if it's a backtest, so you look up about how to check for Boolean values. You could have just done if that is true. That's one way of doing it. Okay, so you could say if it's a backtest. I'm not going to go through coding logic like that. You'll have to do your research. But this is pretty much just saying this property here, it's a Boolean, which means yes or no, a true or false. And if it's true, it means that you're running a backtest. If it's false, it means you're not. So if you just click run on the robot, here, if you just click run, it's not a backtest. If you go to backtesting and you run a backtest from here, it is a backtest. If you run a backtest, it uses the server time, not the local PC time. And this is what confuses a lot of people because the dates will be wrong. The time, sorry, will be wrong. They'll be out. And it returns the local time of your machine if it's not a backtest. And if it is a backtest, it returns the server time. So if I go back, and then it configures, here it configures the timer. So again, it's got the configures and starts the timer. If I right click and go to definition again, or F12, it jumps to that method. In this method, what it's doing, it's creating a timer object from the systems.timers. And what this does, what a timer object does, it allows you to call a method. So this block of code will get called and executed every at intervals. And in our case, every 5 seconds or every 10 seconds or whatever you set in your parameter value there. Because the parameter value is 1, I just turn this off. Because the parameter value is 1, we put it as 1 second, but if you times it by 1000, it becomes 1000 milliseconds. So the timer interval needs to be milliseconds. And that's why I've timed it by 1000. Again, that will just check every second, but you might want the timer to run because it takes up resources every time it runs. You might want it only to run every minute, every whatever time. All these other values are just the timer settings for them to work. Now you might see a red line under there, and previously when we first started, I removed a library that was being used. Now that library was to do with timers, and the assembly reference for that is missing. Okay, so if you want to fix that in this environment, you just click on the little light bulb, and using system.timers, it's added it. And if you go to the top on your using system.timers, it's put it in there. So just in case you forget to add references, or if you don't know what the reference is, it'll automatically do it for you. So as you're writing your code, say you're copy and pasting off the internet and examples, it will actually do it for you. Okay, so what will happen with the timer is this. Every interval, so 1 second, 5 seconds, it calls this method onTimedEvent, which is here. So this block of code will get called, in our case, every second, but you can change that to anything you want. So every second, this piece of logic will get called. Again, enabled timer just starts the timer. We've put some code in here for the garbage collector to keep alive. This piece of code here, again, I need to tell you about it. It's because we've declared this in class scope. What could happen is this. If closing the positions was taking a very long time, the garbage collector, which is a way of releasing memory by the .NET framework, may release this timing object. So what this is doing, this is keeping this alive. The timer object keeps alive. So if you were using the timer for if you were using a timer that was calling a method, and that method was doing something that was taking a long period of time, for example, you want to use this piece of code. This might be a bit advanced for beginners, but I'm just throwing it in there for you to look at. So down here, on the timed event, again, it just gets the current date time. If I right click, I go to definition, again, you can see it just gets the time. So it'll get the current time, and then it says, I'll explain the try and catch in a minute. Then it says, again, if the day is Friday and the time is equal to the stop trading time, stop trading and close positions. So this private variable, which holds the current time, if the day of week is day of week Monday, these enums are great. If the hour is the stop hour, and if the minute is greater than or equal to the stop minute, and if you look here, this is your stop hour and your stop minute. Close all positions. This is another method. And stop the robot. This stops your actual robot. Close all positions. If we hover over it again, you've got the description of it there. If you right-click definition, this is the method that closes the position. It's under the position management region. Now this method doesn't return any values. It then checks to say, is closed all positions. Now, is closed all positions, what that means is it's true. So that's the same as saying is true. If this is true, it's a Boolean, so Boolean is true or false. If I go to the definition of that property, it takes me up to the user-defined parameters where we've said close all positions, default value false. So if you look in here, we've got close all positions, yes. You can choose yes or no. If I go back to the code, go to Control minus and go back to this code, so what this is saying, if the user has selected the drop-down list to say true, is close all positions, it will close all positions. It will go into this next statement. It will loop then. A for each means it goes through each. So positions is part of the cTrader API. Now this object contains a list of all your open positions. So it's like a class object. If you can imagine, it's just like a box that's got all your positions inside it. You can access those positions using this piece of code, a for each statement. So P, I could have called that position instead of P. If position, okay, and then copy and paste that, so that'll make it a bit easier. If position, for each position in the positions, so give me every position in that list of positions. Then what it does, it closes, this is part of the cTrader API as well, close position as sync. This is built into the library here. The same with this one. Okay, so this is saying close this position, this single position, close it asynchronously. Okay, so what it's going to do, it's going to send a message to say close this. Instead of waiting for that position to close, so you tell the broker, please close that position, I'm going to sit and wait now until that position's closed before I go to the next position. If you use async, it will close that position immediately. It will send the message to the broker through the API to close the position. While that's being processed, it will go through the next one immediately, get the next one and send that. So this will be milliseconds. It will just go fire off all the messages off to your broker and say close. So there'll be an asynchronous message going to the broker, 20 say positions to say close. Now when the broker will close those at different times, but this would be very useful if you want to close very fast. If you had 100 positions open and you used this to say close and you had to wait every time a position was closed, the time it takes between the first position to close and the last position might be too long for your requirements, what your requirements are to close. You want to close all positions within. So in your document you could have also put, I want to close all positions within 1 second. That might be part of your requirements. So if that was part of your requirements, then you'd want to implement that with your code. This is why writing requirements is important, because you might have a strategy where you have 100 positions open and you might want to close all those positions 1 minute before a news release. If that was the case, how do you achieve that to close it within 1 minute before a news release? You don't want to rely on your broker having to close those. Even though they'll be fast, you want to build into your code ways of doing it. And this is why design is important. If I just did close position like that, that will close it synchronously, which means it will close a position. When the position's closed, it will then go to the next position and say close this one. So there you go. That's a quick showing you on that bit of logic there. So I'm going to go back now to this bit of logic. Okay, tries and catches. Now, tries and catches is a very good way of catching any bugs in your program and reporting them or dealing with them without it prevent your robot from crashing. So a try, anything inside the try statement saying try to execute this code. If the code fails for any reason, so a logic fails or the code's wrong or something like that, it will catch it here. An exception class is built into the .NET framework. This is the variable that's declared for that exception. Now you can access the exception. I'm accessing the message, but there is much other inner exception, so you can access other things. If you want to know, so what we're doing here, we're going to print to the log file the exception. We're going to actually print that out. When you do your debugging, we'll show you later on how to put a breakpoint in the code and how you can step through each line of code and how you can hover your mouse, or you can look at a quick watch and you can look at the values that are currently being executed or the values that are currently in it. Now debugging your code is invaluable. If you're not debugging your code, again, I guarantee you'll have no hair within 6 months. You really need it. So that is the robot. I hope I've explained it there, and I'm not over yet because what I'm going to do now is go to the cAlgo platform and then go through here running the robot. So, oh, we're on backtesting, that's why. So as you can see here, I've got a couple of trades open. What we're going to do, we're going to simulate a Friday afternoon trade close. So to simulate that, I'm going to modify the code slightly because it's not a Friday afternoon, but I want to test my robot now. I want to test that it works. I don't want to wait till a Friday afternoon. How do I do that? So what we're going to do, we're going to go to the code and we're going to change the, I'm going to close, this is why it's useful to minimize logic, the regions that you don't want to use so you don't get lost. Okay, I only want to look up time validation logic. And in there is the logic. You can also minimize the methods and the comments. And then just work on one block of code without getting confused. So in here, we're going to say if the day a week is a Monday, but it's not, today is a Wednesday. So we're just going to change that to Wednesday. And this is how I would probably just test it. I mean, I could do a back test and test it, but I prefer to do it, test it running it live. And if the hour is the stop hour and if the minute is the stop minute. Okay, I'm just changing that to Wednesday. So I'm just saving that. I'll go to my robot. I'll build it from here. You can build it from here or Visual Studio. So now it's not going to be a Wednesday, Friday. It's going to be a Wednesday, which is today. Because I'm using my local time. My local time here is 9:25. So I'm going to say, so 2400. This is 2400 hours we're using. So 9, I'm going to do 26. So this should close all positions and stop this robot at 9:26. Polling it. I'm going to do a 5-second poll. So, oh, it's 9:26 now. So what I'm going to do, when it does turn to 9:27, I'm going to do now, it will delay 5 seconds. Or it might delay 5 seconds from the moment that's the maximum delay it will be from the moment you start your robot. It'll be between 1 and 5 or 0 and 5. So what I'm going to do is I'm going to run this. And we're going to sit and just wait. Obviously, it's only going to be less than a minute. I'm going to run it now. So what should happen, if I go to the log, it says my local time is 9:26:23. If I go here, when that hits 9:27, all those positions should close and this robot should stop. I hope. And if you could have a look at the server time, it's very different, obviously. Okay. So again, I'm just trying to think of anything else I can think of while it's doing that. That's a good way of doing it. You can do, like I said, you can do a back test, and you can run a back test to actually check that this is working, but it means opening positions, closing positions. For a robot like this, you're probably better off just modifying the code and quickly testing it. There's going to be a 5-second delay, or less. It was less than 5 seconds. There you go. Okay, so that was closing positions asynchronously, and that was stopping the robot here. Now that's just stopping. Now this risk management robot, again, as I mentioned before, what you really want to be using your risk management robots for is I mean, really what you want is to have one robot that manages all your other robots. And what you want is to have a selection of robots, like a tool set, that you turn on or turn off, depending on different times of the day or year or anything like that. So let me just go back. So again, what you'd probably use it for is, if I just go to the one we're using, apply that. So again, you could use these on your cTrader charts. So you could have all your risk management robots listed down here. You could be trading, and we're going to show you this later on when we do the channel trading robot. When there's a channel like this, or there's a channel being formed, you execute the robot. So when you visually see patterns being formed, you select from your tools, your selection of robots that you want to use, and you just use them. So you could have different types of robots on here for different scenarios, and then just run the robot from here. And you know it's running, it's managing your charts there. So you don't, for things like this, you don't need to put on cAlgo. If it's, like I said before, if it's a long-running strategy that's running Monday to Friday, then obviously, yeah, you put it on cAlgo and let it run on that, minimize it, put it on a VPS. But if it's something that's so you're going to be manual trading plus semi-automated trading. So your semi-automated trading is going to take away things you cannot do with your manual trading, or it takes away a lot of the problems. So again, here, if this channel was formed down here, or up here, or if anywhere you see something forming, you could execute a robot when you see it occurring, and you could set the parameters for the highs and lows and stop losses and stuff, and just run it. And you don't have to sit there then and actually just keep monitoring it. And you can proofread, you can backtest this, you can run it on different scenarios. And so having different types of robots depending on the situations on the charts is very useful. The risk management robot here for closing on a Friday afternoon, you can just, again, you'd probably actually use this if you, again, it's for people that have a commuter at work and they don't have time. So you would put this on a VPS on your cAlgo. So this one actually would be on here, and you just run it on your, and then you just minimize the chart on your VPS and just let it run. And that's probably how you'd use it. Okay, so what we're going to show you later on is how this would stop your trading robots. So, but the first thing I think we're going to show you, if I go back to the videos, I think we're going to show you, next we're going to show you how the debugging works. So we're going to go through debugging the code that we just showed you there. We're going to show you debugging in Visual Studio. Then we're going to show you how to write a channel trading robot. And we're going to show you, again, I was talking about there running a channel trading robot. And then what I haven't put in here is this risk management robot. I'm going to show you how you can talk to the channel trading robot. It's a little bit more advanced, but again, it's still under the beginner stage to show you a very basic way of one of your other robots reading a signal from your risk management robot to say, do this, do that. At the moment, the API doesn't have this built in, so we have to do a workaround for it. Again, later on, we're going to show you back and forward testing your robots. We're going to show you, here it is, I put it here, extending the risk management and trading robots to work together. That is the two robots I was talking about there. And we're going to show you using Team Foundation Server. So this is a way of backing up your code and versioning your code and working as teams if you're working as teams. This is very useful to use because if a lot of people lose their code, or they start writing code and they make a mistake, and they think, oh my God, my code is a complete mess. Where was the previous copy I had? I want to roll back. This is definitely every Friday, every day, at the end of the day, maybe checking your code. And then you can just roll back to the previous version you did the previous day or the previous hour. Then we're going to show you a very useful thing, which is test-driven development. This is where you write your tests before you write your development. Now, for algorithmic trading, when you do your requirements, you have set rules, about what you want to happen, and you can make sure that your robot, because the robot is a financial risk of your money. Who would put a robot running on a live account that isn't for, you haven't covered all angles, you haven't tested that something isn't going to go wrong. You don't want to lose money. Test-driven development will stop that happening. It will make you feel secure that you know that each piece of logic works correctly to your parameters, to your requirements. And later on, we'll show you how to do that. Okay, I hope you found this video useful.